We have three presenters today, two of which are from Energy Sciences, Diana Nash and Mitchell Gleason. Diana is a client solutions consultant with Energy Sciences. She has leveraged her professional experience in strategic energy management and sales to provide value to the team in a variety of commercial and industrial markets, including automotive, real estate, construction, defense, and energy industries. In 2014, she was the client representative for the IBEW Local 58 C&E project. She was involved in the project from feasibility all the way through construction integration. So she really knows all of the parts that go into these projects. Mitchell Gleason is an energy consultant with Energy Sciences. He spent the last 8 years honing his skills in the energy efficiency arena, specifically in relation to commissioning, recommissioning, retro-commissioning, energy modeling, commercial and industrial energy auditing operations, and project management and coordination. His task-oriented mindset and ability to work with a wide range of personalities has led to many successful projects over his career. We also have Annie Koch joining us today from Consumers Energy. She's a senior engineer with DNV GL's program and development implementation team. She specializes in technical assessments of high performance and zero net energy buildings and communities. By analyzing these projects through energy modeling, daylight modeling, cost-benefit analysis, and solar feasibility studies, Annie holistically advises a passive sustainability and energy efficiency systems, resiliency, PV sizing, electrification, and LEED. Over the past 3 years, she's aided in the design and implementation of the award-winning Consumers Energy Zero Net Energy Pilot Program, and that's what she'll be talking to us about today. I will now hand it over to Diana Nash to begin the webinar. Thank you.
So good morning and welcome everybody. I'd like to start off by sharing our mission statement with all of you to really shed some perspective on why our team does the work that we do. Energy Sciences' mission statement is that we envision a resilient world where clean, affordable energy and water are available to everyone, and the preservation of natural resources is common practice for everyday life. Energy Sciences is a leader in energy education, and we've conducted training for really a multitude of topics, which include the new Michigan Energy Code and ASHRAE 90.1 2013, multiple HVAC topics, monitoring-based commission, and many others. So we've also published numerous technical blogs and other technical publications. We recently actually had a blog on zero net energy projects. Our team provides a variety of services that are listed on this slide, ranging from facility assessments all the way through to turnkey lighting projects, and of course, zero net energy solutions, which, as you know, happens to be the topic today. Today we'll be discussing how to leverage collaboration to complete a winning zero net energy project. So whether it's new construction, a redevelopment project, or a renovation, such as the IBEW project, the steps may be a little different, but in general, most of the principles remain the same. And so this presentation will primarily focus on renovation projects, and our team has first-hand experience with an actual zero net energy project, which you'll be hearing about later in the webinar. Some of the learning objectives for the first half of this educational session are, first of all, understanding what zero net energy is, why zero net energy is important, the critical steps to completing a zero net energy project from first-hand experience, and also the zero net energy certification path. Just a brief disclaimer here, throughout this presentation, we will be referring alternately to zero net energy, zero energy buildings, and net zero energy as synonymous with zero net energy. This presentation is meant to be an educational primer and is really intended to provide an overview of zero net energy for existing buildings. This overview is not, however, exhaustive, and instead we designed it to be really to highlight the significant criteria and it gives us all a good starting point for facilitating and executing a successful Z&E project. So that was the goal of this webinar. So first we want to explain zero net energy from a bird's eye view by talking about what zero net energy really means as defined by different important organizations. It's important to understand that Z&E has been defined slightly differently depending on where you get your definition from. So here's two mainstream definitions on this slide. So the International Living Future Institute, or ILFI, defines zero energy buildings as 100% of the building's energy needs on a net annual basis must be supplied by on-site renewable energy. There's no combustion allowed. The U.S. Department of Energy, or DOE, says a zero net energy building is an energy efficient building where, on a source energy basis, the actual annual delivered energy is less than or equal to the on-site renewable exported energy. For this presentation, however, we will be focusing on the ILFI definition, and primarily because it's the only organization that offers certification for Z&E. There are numerous compelling, groundbreaking benefits with a zero net energy project. So let's examine some of those benefits on the next couple of slides. It's important to understand the value that Z&E projects bring to the table, as it's multifaceted and really not limited just to monetary gains. It can also include all or some of the following benefits. Of course, first, we all know about the energy savings. They're the first and most well-recognized benefit. There's plenty of case studies that support energy efficiency strategies of all kinds, and lower operating expenses can also be expected due to energy efficient systems and the load reduction planning through design. Reducing energy consumption results in lower carbon emissions, which benefit the environment. So this is another way that zero net energy projects benefit the community. Additionally, significant marketing opportunities can arise by doing a Z&E project because the facilities can be used as a training for facility stakeholders and the community as a whole. Z&E projects will potentially lead to better resiliency during power outage situation or other emergencies, and part of that depends on the backup systems that are in place. I would also argue that a Z&E project establishes your organization as a technology leader, lending credibility to the goals and aspirations of the building owner or the organization involved with the project. The last benefit that I will mention is that it can give you a competitive advantage in your specific market, and we'll be seeing this with the IBEW later, because of the things like lower operating costs, marketing advantages, brand recognition, and of course, one of my favorites, attracting and retaining employees. So we'll be reviewing a real life case study later that supports all of these high impact benefits. Now let's talk about the other significant benefits for stakeholders, the collaborators, and the community. If the building owner has tenants, they can also benefit in some other ways. For example, they're typically able to attract tenants who are willing to pay a higher price per square foot for the space, since their utility bills are lower or even non-existent. So compared to other multi-tenanted office buildings, the Z&E buildings would be more attractive because of the lower or non-existent utility bills. Additionally, a benefit for the building owner is that the market value of the property will increase significantly as the operating costs are reduced, because the way commercial buildings are valued in the market is through the capitalization rate, or cap rate. And so the cap rate is the way that commercial real estate people evaluate or value commercial buildings. The tenants will also benefit based on the advantage of greatly reduced or no utility bills. They may also benefit on the corporate side if they have a corporate commitment to sustainability or a carbon emissions reduction strategy. Numerous trade organizations benefit not only from the labor requirement for these projects, but also the training experience that naturally occurs with these type of cutting edge projects. Lastly, the project team greatly benefits just by their association with the Z&E project. I can attest to this personally. The collaboration aspect of these projects provides a platform to develop strong industry relationships, and it has definitely served all of us well that participated on the project. Further proof that collaboration is the key driver in a Z&E or Z&E ready project can be found in the point that high impact design and proper use of critical calculations are really the key foundation of any zero net energy project. And therefore that topic is highlighted throughout this presentation. At this time, I'd like to hand over the presentation to Mitchell Gleason to talk about the design process and how critical the calculations are.
And good morning, everybody. For simplicity and for greater understanding, we've broken the design and calculations process down into 4 steps. We'll begin by talking about each step as we move through the next several slides. So first and foremost, the most important step is defining the project scope, as 67% of you agreed with, and assembling the project team. Properly defining the scope will avoid costly errors downstream, and assembling a collaborative team is the single most important thing that you can do to drive a successful outcome on these projects. From there, you can move into creating the project baseline, which is the second step. And it's important to have an accurate starting point, and documenting the baseline is critical to the certification process as well, which we'll touch on later. Once you have set the goals for the project and calculated the baseline, the third step is where the team identifies key project parameters. That would be such as stakeholder roles and also identifying potential roadblocks. The fourth step is where the construction or implementation project tasks and schedules are further developed and communicated to the team. And with that, let's take a closer look at each step. So Z&E projects are a special breed of projects because you are not only designing a facility that will serve the owner, the tenants, and the community for years to come, but energy becomes a main driver in the design and also the function of the facility. So the owner or owner's representative's role in this is to initially set the goals for the ultimate project, which involves short-term, intermediate term, and long-term goals. One of the first questions to ask in these projects is, what are the energy and sustainability targets or goals for this building? The owner needs to define that what type of certifications they are going to pursue. Again, like I said, we'll talk about certification a little bit later. Another question for the owner or the owner's representative is, are there any restrictions or limitations that they are aware of, or are there any particular types of systems that they do not want to pursue in these projects? The owner may know some of these things already, or they may need to complete the feasibility process to flush some of these things out. During the first phase, it is important to set goals and complete a feasibility assessment. It's important to understand where you are and where you're starting so that you can properly plan for how to get to where you ultimately want to be with this. A feasibility study can help showcase the building's current strengths and weaknesses, and that also empowers the owner and owner's representative to make proper decisions on the project design. So there are a number of things to consider regarding the design, and it's important to always keep the owner's requirements in mind. We have already touched on that subject, so I won't go too much into that, but understanding the type of building and the usage requirements is important. One thing that is frequently done is to interview occupants of the building to gain a deeper understanding of the building's use, their workflow patterns, and some of the indoor comfort issues that they face. It's critical to know the sustainability goals of the owner as well, and equally as important, you need to know upfront what the sustainability goals are for any certification that you will be pursuing. For example, before you remove any materials from a building or purchase materials, it needs to be documented and done sustainably. The on-site renewable strategies should have been discussed at this point and taken into consideration from the design charrette and further developed at this stage as well. Once it's understood what the end goals are for the project, it's time to flush out the project baseline, or the starting point in that sense. During the second step, identifying the project budget will really drive this approach. The budget and the cost-benefit analysis will allow the financial stakeholders to make decisions about financing options, and will help the team to collaboratively drive the technology approach. So in step 2, the more data you have, the more informed the project design and implementation will be. It is important to collect as much data at this point as possible related to the building and its functions so that informed decisions can be made regarding the design. Unlike other projects, it's incredibly difficult to change course once the project is in motion. So changing even the smallest item can impact the energy profile and could cause a failure to reach the goal of Z&E. For this reason, having the key decision makers and the team players involved and gaining their buy-in from the beginning will help avoid unforeseen changes. The baseline study is a critical process in the second step, and it also functions as a means to collect baseline data. The baseline study consists of a level 2 or 3 ASHRAE assessment, which will generate a report detailing all of the potential energy conservation measures, or ECMs for short, that are possible to reduce the baseline to its lowest possible level. Prior to starting, and this is all happening prior to design. So it will also be a good indicator of how the systems can be adapted to eliminate gas and convert systems to electric as well. So when we're talking about the ILFI certification, it requires the elimination of combustion, which means everything has to be electric. So this process to convert gas systems to electric is now being referred to as beneficial electrification. Other potential components of the baseline study are preliminary modeling, air infiltration studies, gap analysis, and identifying funding sources. So I think energy modeling and optimization is really important, and I think it's important to discuss how powerful these tools are, especially to leverage on a Z&E project. Technology has come a long way, and we are able to take a physical building and recreate it inside of a virtual model. We can then tune that model so that it responds to a full year's worth of weather data and matches the actual energy bills that are being produced on site. So this is important because you can take that and then adjust building materials, equipment, efficiencies, and with that you can truly see how they impact the facility before it's even complete. This can really help drive the decisions as to where money will be spent, as you can literally weigh the cost effectiveness of each item being considered for use in to reach your end goal in zero net energy. There are some downsides to modeling though. So one downside would be incorrect correlation to actual data. It can be really easy to make a model look like it's calibrated, but only experts are able to do it properly, as there are both an art and a science involved in the process. I recommend that if you do go that route, that you ensure the firm you choose has a successful track record for these type of high performance buildings. Step 3 in the Z&E process deals with all of the critical controls, such as the stakeholders and their roles, along with roadblocks that will potentially arise. It is crucial to success to involve everyone early and often. Clear and open collaboration leads to successful projects. You'll hear us drive this point home throughout this entire presentation. One of the more important roles in a Z&E project is the involvement of a third-party commissioning provider. Having an extra set of eyes to ensure that equipment is installed and operating as designed will help avoid big problems down the road, especially when the commissioning provider weighs in early in the design phase. It also provides another perspective. On that note, the commissioning provider must be careful not to function as part of the design team if they are to be a true third-party commissioning provider. But however, they have a unique perspective on what can go wrong, so it makes sense to have them weigh in at this point. In my opinion, having a knowledgeable, collaborative team that is engaged through the entire process yields phenomenal results. Identifying roadblocks during the design phase allows for a proper schedule and timeline to be formed and executed. These roadblocks can range from site issues, legal issues, project guidelines, critical building controls and equipment functions, etc., etc. Bottlenecks such as lead times and trade coordination can cause issues if not addressed up front, and potential operating issues with newer technology can impact a project and should be evaluated as well. For example, with this, communication issues between systems and controls is very critical. The fourth step becomes much easier and less costly if all of these issues are addressed prior to the implementation phase, which brings us to step 4. Constructing the project timeline requires collaboration with all of the stakeholders, including the owners and owners rep, consultants, architects, and contractors. All the work leading up to this step should make compiling the schedule and timeline a straightforward task. There are several key factors for success to keep in mind as you complete the timeline. One of them being collaboration is a key factor, like I said before, and we're still drilling that home. And you can probably, as you have noticed, it's something that's incredibly important. It is a consistent theme throughout this webinar, as I said before, and that is one of the main focuses. So also understanding construction and equipment lead times is critical and frequently becomes a moving target, especially given the current market challenges. A working knowledge of industry best practices will serve the team well, in addition to having experience with custom projects. And then also, if a team is knowledgeable about project bottlenecks and roadblocks, it goes a long way to avoid pitfalls later in the process. Congratulations, the hard work is done at this point. Now it's time for implementation. So implementing, measuring, and verifying the ECMs that were identified through the studies completed during the feasibility phase, along with any new systems that were designed, will successfully demonstrate to the client once everything has been measured and verified that things have been installed the way they should. Proper measurement and verification is critical to any certification process as well, whether it is the ILFI Zero Energy Certification, LEED, or other certification programs. Much like the fourth step in the design and calculations phase, implementation should be a straightforward task since you have a plan, the schedule, and a committed team that knows what needs to be done. The keys to successful implementation are a good quality team around you and a good manager to execute the plan as designed with open collaboration and communication the entire way through. Verification should be straightforward as well, especially if there's a commissioning provider on the project. By this point, they will have instructed the controls contractor on what trends are necessary for proper metering and monitoring of the system effectively and can provide proper training on the equipment being controlled. Once the data has been collected by the system, you can compare to where the building started versus what your goals were for the project. And as you guys know, this is called the baseline versus proposed evaluation. If there was an energy model involved, you can compare the projected model with the actual bills to verify where you stand. So in summary, both implementation and verification will be successful if you have a good team around you and due diligence was taken during the design. So up to this point, we have discussed driving forces behind a successful zero net energy project. Now we can take a little time and talk about meeting the certification requirements. And I'll turn it over to Diana Nash to talk about certification and an actual case study.
The ILFI, sorry, that's a tongue twister. The ILFI Zero Energy Certification was created to allow projects to demonstrate zero energy performance, building an advanced cohort of projects with the integrity of a third-party performance certification. So this program is the only international zero energy certification program, and the ZE certification certifies that a building is truly operating as claimed, harnessing energy from the sun, wind, or earth to produce net annual energy demand through a third-party audit of the actual performance data. So it also provides a case study platform for your project to inform and accelerate other zero energy efforts throughout the world. And ILFI celebrates a significant accomplishment and differentiates both the building and those responsible for its success in this quickly evolving market. So we're seeing a lot of these projects pop up. And you're going to hear from Consumers Energy later about how they're driving projects to happen as well in the state of Michigan. So next, we're going to talk about an actual case study, which is the IBEW Local 58 Zero Net Energy Center, which is in Detroit. The Z&E Center was the first Z&E project in the Midwest of its size that I'm aware of, or that we were aware of at the time in 2014 when we started. And I was involved and held all of the contracts representing the owner throughout every phase of the project, from feasibility through construction integration, in my former role with Green Team Coalition. In this section of the webinar, we're going to learn about, first of all, the mission and goals for the Z&E Center for both the owner and the team. This is obviously a really significant variable. So also we'll define the steps and deliverables, and additionally the benefits for the stakeholders that occurred as a result of the IBEW Local 58's commitment to complete the project. And the final learning objective will be how the building owner leveraged a consultant, Green Team Coalition, my former company, to execute all phases of the Z&E Center project. So the case study we're going to look at is the IBEW Local 58 Zero Net Energy Center in Detroit and Corktown. And I was initially approached by the leadership team at the IBEW Local 58 about their interest in taking their Corktown headquarters, which is a union hall, to zero net energy. Their goals included energy savings, of course, it's always the goal, but also to create a community center focused for outreach within the city of Detroit that would showcase member and contractor skills and innovation. This was the driving principle behind the project. Corktown has a unique history, and at the time when we started the initial phases in 2014, Corktown was in general a pretty depressed area. There wasn't much going on, and the community was very welcoming about the project, considering that it marked the beginning of a new era for Corktown, and I would say for Detroit as a whole. It really started turning at that point shortly thereafter. So I cannot stress enough, again, the power of collaboration that Mitchell has been talking about and that I mentioned in the beginning, because we really leveraged the collaboration throughout the entire experience. We had amazing people that were all handpicked based on their skills, industry knowledge, and their relationship with our team. And the project was an incredible success because of the people and the client's commitment. It's important to understand where we started from an energy perspective. The IBEW Local 58 Union Hall is a 33,000 square foot facility. It's block and brick design. The building had a significant glass curtain wall. It had significant glass curtain walls when we started, and very little, almost no insulation. The Energy Star rating was 37, pretty dismal. We had a stretch goal of 75. So obviously we had a very long way to go. The Energy Usage Index, or EUI, was 123 kBTUs per square foot annually, and the goal was 10 to 30 kBTUs per square foot per year. The energy costs ranged from $63,000 to $65,000 a year, with gas representing about 65% of the total energy consumed, not surprising in these older buildings. And then electric was about 35%, which is pretty much, industry standard, I would say. It's important to note that we eliminated gas consumption altogether through the implementation of technology. As Mitchell mentioned, this is referred to as beneficial electrification, simply because electricity is easier to reduce to zero through renewables. So beneficial electrification is something that we're all going to hear more about over the next several years. There was a defined mission for the project, as well as many challenging goals. The mission and the goals included, first and foremost, to provide a state-of-the-art training center that would walk the talk for the electricians and the electrical contractors at IBEW Local 58 and NECA, which is the National Electrical Contractors Association. The intent was also to create an environment that engaged the community and future workers. We sought to design a facility that would be a sustainability landmark for Detroit and for Michigan as a whole, and even the Midwest. Another goal was to develop a facility to be utilized as a showcase for labor and the unique skill sets of the IBEW NECA team. The idea was to reduce the baseline energy to the lowest level possible through technology and workflow. The design concept was to generate as much energy through renewables as the building consumed. An important goal was to promote clean energy, implement sustainable practices, and reduce carbon emissions. And as with any energy project that we've looked at over the years, the primary driver is to reduce the operating costs and often increase the real estate value. Lastly, most importantly, the end game was to create an energy demonstration center that would be available for community access to benefit numerous organizations and the industry as a whole. So there was a very defined mission and a lot of very challenging goals when we started with this project. The project resulted in many benefits and contributions to our local economy and to the environment. The first benefit was that we utilized the local union contractor base, who at the time really needed the work. It was a pretty slow market. Other benefits were that many of the materials were made in Michigan, such as the SIP panels, even though we didn't go for LEED accreditation because we were going beyond LEED. We wanted to follow some of the LEED principles, and it was important to certification later on. So the SIP panels, or structural insulated panels, were manufactured in Michigan. And additionally, the energy and sustainability measures did exceed LEED criteria. So there were a lot of, all of the contractors, the consultants, and a lot of the materials were sourced from Michigan-based companies. So there's a numerous ongoing contribution to society for the Z&E project. One unique example is the community engagement. There are significant benefits for the community, and the IBEW and NECA have remained committed to that example. There were and currently are contractor, technology vendor, and trades training opportunities ongoing. They're looking at battery storage now, and so they are continuing to develop the project and stay committed to the project. We already touched on the Energy Demonstration Center concept as part of the mission. The facility provides a wonderful venue for demonstrating energy efficiency, renewable energy, the benefits of building automation system, advanced lighting technology, and many other technologies. So it has now become a benchmarking icon for Michigan and the Midwest for Z&E. And the project provided work for numerous contractors for a large project, again, during a relatively slow market. We employed a lot of trades on the project and a lot of consultants. The facility continues to provide a venue for energy and sustainability stakeholders to engage. For example, Detroit 2030 District, if you all know Connie Lilly, AIA, the PACE folks, and many other organizations. It continues to be a model for collaboration or among the people in the energy industry and for the trades. The project drives momentum for other Z&E and renewable energy projects by providing a state-of-the-art case study. The project phases started with the discovery phase, which is where we started to evaluate the feasibility of Z&E. And then we began the design, engineering, and planning phase, which is where the collaboration really became critical. From there, we went into bid, contract, and award process. And the implementation and the construction phase was where the rubber really hit the road, so to speak. Measurement and verification was the last phase of the project. And of course, that's important for certification. As a consultant in my former role with Green Team Coalition, our path to completing the goals included conducting ASHRAE energy assessments, air infiltration study, and thermal imaging, which provided data and details to create the baseline and identify energy conservation measures, which would be implemented prior to the renewable energy design. Next, our collaborative team performed building modeling and benchmarking, and we then conducted a gap analysis comparing the baseline to what we needed to ultimately do in order to meet our stretch goals, which helped out our basis of design. The final steps were the Z&E design, project management, and implementation phases, and beyond these tasks were the final steps, which consisted of the commissioning and the certification process. There were some eye-opening audit results. We followed ASHRAE guidelines for the ASHRAE Level 2 audit. Specific tools were used to calculate data. The Energy Star Portfolio Manager and Retro Efficiency AEA software for benchmarking and modeling were leveraged. And the ASHRAE Level 2 audit identified 39 energy conservation measures. The variables that we used for these calculations were a complete description of the existing equipment and systems, the current annual energy consumption before implementing any ECMs, the facility annual hours of operation. We estimated the projected capital costs for more efficient equipment and systems, and we used return on investment criteria for each system. Let's talk about the gap analysis for a moment, because it was a very critical step in the process. We determined that we needed a method to compare the baseline to where we ultimately needed to be to reach our stretch goal of Z&E. So we really had to invent the gap analysis. And so the purpose of the gap analysis was threefold. First, we needed to identify areas where more information was required. Additionally, we wanted to carve out the details around which decisions needed to be made. And lastly, we outlined all the necessary steps to achieve our minimum and stretch goals. The gap analysis report covered the energy reduction plan based on the testing, studies, and modeling, a renewable energy strategy, which was based on a preliminary feasibility study, projected consumption, and a concept design. And the report covered the process that defined the owner and team's goals and identified questions and challenges that needed to be addressed. We included a preliminary proposed schedule in the gap analysis report, as well as a preliminary budget for anticipated costs for the design and installation of equipment and systems. The primary technical components, which are now highlighted in the website that we'll mention in a minute, are the state-of-the-art LED lighting and controls were installed throughout the building. There's over 500 LEDs, which were designed by Energy Sciences and installed by Motor City Electric, who's an IBEW Local 58 contractor and a member of the National Electrical Contractors Association. A geothermal grid, which is a vertical closed loop ground heat exchanger system, was designed by SES. A heating and cooling VRV system was installed by Conti Mechanical, who's also an IBEW Local 58 contractor. The structural insulated panels, or SIP panels, were installed by Jasmine Construction. The SIP panels effectively serve as wall insulation. And there weren't at the time a lot of projects that had utilized SIP panels in Michigan. They've been used a lot in other states. So there was a little bit of a learning curve with the installation, but once we put up the first panel, all the other ones went up very well, and it's a very cost-effective way to insulate a building. Energy efficient windows were installed and were provided by Edwards Glass. The EPDM membrane roof system with R50 insulation was installed by JD Candler. Materials were supplied by North Coast Carlisle. Mark Haggerty from Michigan Solar designed the 174 kilowatt solar array, and Metro Controls upgraded the existing automated logic building controls. So I'm proud to say that our collaborative team met the goals, delighted the owner and the stakeholders, and created a space that's a backdrop for a plethora of events, tours, and training sessions. The team accomplished a lot throughout this project. So the total energy bills for electric range from $0 to $1.67 a month on average. Today, remember, there's no gas bills. We completely converted everything to electric and renewable energy. We achieved an Energy Star score of 83 based on the new rating system. If you recall, we started with an Energy Star score of 37. And the energy usage index is now at 23 kBTUs per square foot per year versus the original 123 kBTUs per square foot per year. And very importantly, the building meets all occupant and comfort expectations. IBEW Local 58 launched a website in 2019 for the Z&E Center. The website covers the 9 distinct energy producing, energy saving systems that were designed into the building, and I'd encourage all of you to visit the web page to learn even more about the project and IBEW's continued commitment to energy and sustainability. The 9 energy producing and energy saving systems that are highlighted on the website are outlined here on the slide. So the geothermal grid, heat pumps, solar panels, virtual energy monitoring, solar DC to AC inverters, over 500 LED lights, wall insulation, roof insulation, and energy efficient windows. We have about, if we did the whole content, I have about 3 hours of content that I could talk on this project, so we had to condense it, but overall, these are the highlights of the case study. And at this time, I'd like to hand it back over to Annie. He'll talk about the Consumers Energy Zero Net Energy Pilot Program. And if time permits, we'll have time for hopefully a few minutes for a brief Q&A. So we're excited to have Annie on, Annie Koch from DNVGL and Consumers Energy.
Thank you everybody for inviting me to join and represent Consumers Energy Zero Net Energy Pilot Program. Again, my name is Annie Koch. Got my email down at the bottom of the slide here if you need more information after this presentation. So I have been involved in the pilot program for the past 3 years. It's been up and running and available to customers in Consumers Energy territories, specifically in the electric territories. I am the program manager, and we designed this as a way of trying to help projects go through the process of zero net energy. We're not technology specific, we are process specific and energy reduction specific. As an energy efficiency program, we are incentivizing the energy reduction side of things. So technically, it's a zero net energy ready program. So we require a certain percentage of energy reduction, but we do not require the energy generation side. We recommend it, but we can't incentivize it, therefore it's not a requirement. It is available to both commercial and multifamily mixed-use projects. And we are an all-electric pilot program. So as both Mitchell and Diana were speaking to the benefits of all-electric, that is a requirement for our program. And it also lines up with Consumers Energy's clean energy plan and carbon reduction goals as a whole. And also lines up with achieving any types of zero net energy certifications down the road. For our program, we offer participants $1.50 per square foot. The majority of the tasks that we require projects to go through in the program are typically the design, the commissioning, the energy modeling. The added effort that goes into doing these typically comes out on a square foot basis as opposed to a kilowatt hour saved basis. So that's why we structured our payments in per area. We also pay for any zero net energy certifications projects wish to pursue after going through our program. So we pay for the added cost to get that incentive for that certification. So with like ILFI, as was mentioned previously. So to recap some of our energy reduction requirements, this is compared to code minimum if it's a new construction building, or it's compared to existing conditions if it's a major renovation. So ideally we want projects to earn a 25 kBTU per square foot per year EUI goal, and EUI, as was mentioned earlier, is energy use intensity. If that cannot be reached for whatever reason, we require a 30% energy reduction for major renovations or 40% for new construction. Next slide, please. Okay, so the problems that we were trying to solve by implementing this program was to help with proof of concept. As was stated earlier, there's not a lot of zero net energy projects in the Midwest, let alone in Michigan. There are a couple here and there, but especially when we started this program, it was really just the IBEW that was up and running. So proof of concept that it can be done in the Michigan state, and the cost effectiveness of it, helping to offset that with these incentives and prove that this can be done in this climate. Some of the things that we've implemented in our program have been putting together deliver a Zero Net Energy guideline to go through what this process is and how to help projects go through it. The flow chart that you see here is what our program is set up as, and I'm happy to say this lines up a lot with what both Mitchell and Diana were talking about earlier with the different stages of going through for a Z&E project. So for us, we have our preliminary design phase, which is where you're selecting and working to an EUI goal, and this has buy-in from the owner that's setting the stage and having the entire design team and commissioning team, everybody there from the beginning, working towards that same goal. Then in the advanced design phase, that's where you're going through and designing to that EUI goal. And that's where you're doing energy modeling and cost benefit analysis, really making sure that you're selecting the appropriate energy conservation measures for your project. Then in the construction phase, that's where you're going to have working through what your M&V plan is and your commissioning, and really ensuring that the EUI goal that you designed to is being reached in the field. Oftentimes, there's so many people coming and going from a project over the years that you can miss certain opportunities by accidentally ordering the wrong piece of equipment or installing it incorrectly. And then in the last two phases, there's the measurement and verification phase, where we require 12 months of post-occupancy measurement and verification that you in fact did reach that goal that you intended on reaching. So for our program, we currently have 11 projects that are kind of in the last, either entering into their measurement phases or just starting them right now. So we have a large variety of projects in our program due to the fact that we are incentivizing a Z&E process. It's an integrated design process, and it can be applied to so many different building types. It's easy to say, oh, you know, we can't do that. We have high energy use for one reason or the other, but everyone can have a % reduction goal. So we really want to have things opened up. We have buildings as small as 5,000 square feet, and then other ones that are 200,000 square feet. We have use types like a school that has really low energy use to begin with, but then we also have an art museum. So you can apply it to any different building type, and it should be available to all. And that's what we are trying to prove here. And we are currently open for enrollment, adding new projects into our program. So please contact me at that email if you have any projects that you'd like to discuss. Thank you very much.
Thanks, Annie. So at this time, we'd like to invite people to ask questions. And so please feel free to enter your questions, and we'd be happy to answer.
Awesome. So we have 2 questions already in the box. I will go through them now. So the one is from an attendee that is located in Virginia. They said, as a PACE project manager, I'm developing 4 Z&E projects in Florida. How do I find the right team who does energy models, closed cell foam versus blown insulation, geothermal, radiant heat cooling, and hot water?
Yeah, so that's a really good question. And I think that one of the ways you can do that is to approach the local tradespeople. So, I mean, I can certainly help put you in touch with some people that can help with the project. And I would say that having an owner's rep with the relationships in your market is important, but also having someone on the team that understands the process, you know, is important. But I think really a good starting point is going to the trades organizations and checking in with them to see who they would recommend, and they know what skill sets their local trade unions have as far as being able to execute those types of projects. Does anyone else on the team want to weigh in on that? Mitchell, Annie?
think ultimately it depends on who you trust, who you've done work with in the past, and also looking for a good track record. So if you don't have anybody in a particular area, reach out and see what experience they have in those types of projects. If they actually have experience, I think that goes a long way.
Yeah, and it's tough right now to find people who have experience in Z&E because there haven't been that many, projects. But if you want to reach out to me, my contact information will be up on the last slide. If you want to reach out to me, I'm happy to have an extensive conversation outside of the webinar and kind of try to help guide you as best I can, kind of explain to you how we put our team together.
Someone in the audience also said you can contact local ACCA for geo applications.
Great.
So another question we have, this is for Annie. What territories or states is Consumers Energy located in?
Consumers Energy is in the state of Michigan, and their territories spread pretty much throughout the state, mostly on the western side of the state and northern, but there's a little bit in the center as well, less so in Detroit and eastern Michigan areas. But I can, let's see if you want more information, I can also send you some links where you can get that details.
Thank you. Someone else also mentioned from the last slide you had there, Annie, they said, I'm in love with phase 5. With any conversion measure, the only way to measure the success is by checking the meter and seeing a change. That's what it's all about. Great job.
Thank you. And something I didn't mention before is we require that the submetering to be done per end use, which really helps with identifying any issues once you're up and running. If you see a spike in energy consumption, being able to know that that spike is coming from your pumps somewhere really helps to solve the problems.
Is there training or certification for Zero Net similar to LEED?
That would be through the ILFI, and so you can Google that, and they have a website, or if you want to send me an email, Diana@esciences.us, I can send you the link to their website. So that's the certification body. Oh, thanks, Mitchell popped it up. So that's my contact information. So feel free to call me, email me, text me, instant message me. I don't know.
Yes, and we'll also make sure that we go through the questions after the webinar and make sure we had provided full answers, and we'll follow up too if we have more information we can share with you.
Yeah, we're always happy to be a resource. So we want to see more of these projects happen, and however we can help drive that, we're happy to do that.
Definitely. Another question we have, typically approximately how much cost per square foot for these applications?
Boy, I don't really have a range for that. I don't know if Annie, has Consumers Energy done any do you have any data like that?
It's hard. We've looked into it, and we're trying to gather information as the projects in our program continue through and have more real data for it. But there's just such a high range, especially if you have a new construction versus an existing building that you're retrofitting. Yeah, it's tough. I'm sorry, I don't have a hard number for you.
I do know that I benchmarked the building when we were doing it, and the cost compared to the cost of retrofitting versus new construction, it was probably about 25% of the cost to renovate the existing building versus building it from scratch.
Awesome. So another question or comment we have here. So I think the code should be reduced to EUI. Given a type of building, you hit this EUI. Contractors then provide a performance contract when applying for a building permit. The building design's up to the contractor. They can do whatever they want, but 1 year later, the meter tells the story. Did they meet the code or not? And if not, did they go in and retrofit until they meet the meter requirements, utilizing the performance contract if necessary? That makes sense.
Yep, I think we're all saying it makes sense at this point.
Anybody else that have any questions they'd like to send in? Alrighty, well, I think that's all the questions we have today. Like Diana said, her contact information is there on the screen. So feel free to reach out whenever you have a question.
Thank you, everybody.
Thank you for joining us. Have a great day.